Okay, so there are so many mistakes on the interactive version that today I have decided that I'm not even gonna put on the link for you because I try and go through all the questions before I send you the link to make sure there's no mistakes. There had been some mistakes in the past, but this section, I don't know what's going on. There are just way too many wrong stuff, wrong things. Anyhow, here's the essential question. How do you calculate a conditional probability? Of course, you need to know some vocabulary words like conditional probability, and that is called the probability of A given B, and you write it like that, okay? And so you're looking for the probability of A, and then at the bottom is B, because B already happened, okay? So there you go. The probability that event A occurs given that event B has already occurred. So that's a really important thing, okay? So then the textbook goes on to explain to you, this chart over here, okay? So let's try and work on this together so you understand. Okay, there's event A. That's the event that a participant did not get a headache, okay? This is A, did not get a headache. B is they took the medicine. So to the nearest percent, what is the probability that a participant who took the medicine did not get a headache, okay? So then let's think about this. A participant who took the medicine, so it's all the people who took the medicine. They took the medicine, so that's 65 people, okay? Who took the medicine. 65 who took the medicine, right? And so that's B, right? So I'm going to put B down here, 65. And then how many did not get a headache? So out of the 65, how many had no headache? This is headache, this is no headache. So it's going to be 54. And so that's it. If you calculate this, I don't know, I think it's going to be 80-some percent, lower 90s, higher 80s, okay? Something like that. I do not have a calculator with me handy right now, so you'll just have to do it using your calculator yourself. Okay, now let's scroll down. And then it says to the nearest percent, what is the probability that a participant who did not get a headache took the medicine? Okay, did not get a headache. No headache. If you go all the way over here, the total people who did not have a headache is 76. So out of the 76 people who did not get a headache, who took the medicine? Okay, out of 76, who took the medicine? Only 54. So it's 54 over 76. Okay, 54 over, did I say 56? Let me go back. All right, never mind. I forgot all my number. Probability that a participant who did not get a headache, no headache, is 76. 76. 76. Took medicine. 54, 76. 54, 76. And you got to calculate this, okay? Because how many people did not get a headache? 76 people did not get a headache. And how many took the medicine out of those people? 54 did. So again, do your calculations and you'll get a percentage, okay? If you don't know how to use your calculator, you gotta go 54 divided by 76, and that will give you point something something, and so you gotta multiply that by 100 to get the percentage. Okay? And yeah, so you can keep going. They're just trying to explain some things to you. Okay. And then the second thing they move on to is the same thing, okay? When you want to find the probability that A happened, given that B happened, you can use relative frequencies, okay? So what you have to do over here, if you don't understand what relative frequencies mean, it's just probabilities, okay? And frequencies mean counts, okay? So basically you count it. There's 24 people who have a headache, and out of the 24 people, 11 people took medicine. When you just count how many people, these are called frequencies, okay? This is a frequency. But when you change everything into a probability, we call it a relative frequency, and that looks like this chart over here. Okay, so then how do you change everything into a probability? Well, that's pretty simple. All you gotta do is go like this. I'm going to show you two charts, and you go. You see how everything is out of 100? That basically means 100 people were contacted and 100 people were asked the questions. Do you have a headache? Did you take the medicine or no medicine, right? And out of the 100 people, all these people, this is how they answered. If you add 1, 2, 3, 4, these columns together, you get 100. If you add 11 and 13 together, you get 24. 11 and 54 together, 65. So it goes like that, like this, and of course 100 means all the people here, all the people there. Okay, so what's the probability that a person has a headache and took medicine? It's 11 out of all the people, right? 11 out of 100, so that's going to be 0.11. What is the probability of somebody who has a headache who did not take medicine out of the whole thing? 0.13. So you can see how we just have to divide everything by divide everything by 100, right? So this is your answer. And so once you're done with that, now you can see all your relative frequencies, right? Okay, so then using that, you can go ahead and solve all these other questions, okay? And again, this is actually not that difficult, but let me try and shrink the screen a little bit because it's difficult to show you everything in the same screen. Okay, so there you go. In this chart, I had all my numbers and now they're all gone. Okay. And so how can I go back? Let me try and pause it for a little bit and write down all the numbers. Okay, so what I did was I wrote everything down again. Oh no, but then the pause screen is there too. That really sucks. Okay, never mind. Gonna have to go back where I am doing this all over again. Okay, so there you go. This is going to be 0.11. And now let's solve this problem. Recall that event A was what? A participant did not get a headache. And that B is what? Participant took the medicine, right? So use the relative frequency. The relative frequency table would be this one with the decimals. From step A to find the probability of A. What is the probability of A? Well, the probability of A is the probability that a participant did not get a headache. Did not get a headache. No headache is 0.76 out of all the people will be how many? 1. Okay, so out of 1, only 0.76. Okay, so this is going to be 0.76 over 1. But who writes over 1, right? So it's just going to be 0.76, right? And what is the probability of B? And what was the probability of B anyway? Probability of B was people who took the medicine, okay? Taking the medicine. Oh, that's 0.65 over 1, okay? But nobody writes over 1, so that's 0.65, okay? So then, what is the probability of the intersection of A and B? The probability of the intersection of A and B is just pretty much everything, okay? Which is people who did not get a headache and did not take the medicine, okay? Did not get a headache, no headache, okay? No headache, and then did not take medicine, no headache, did not take medicine, which is what, right here, 0.22, right? Okay, so then that's really important, okay? So did not get a headache, no headache, and took medicine. Oh, my bad. No headache and took medicine is actually 0.54, not 0.22, okay? So I'm going to have to erase that. Okay, because A was did not get a headache and B is took the medicine. So no headache, took the medicine is actually 0.5. So it's going to be 0.54 over 1, which is the same as 0.54. Okay, so we got these 3 answers, which looks kind of messy, but that's just how it is, right? And then what do we do? Let's take a look at the next question. You found the conditional probability. Okay, the probability of A given B, and that was 83%. I guess up there when you calculate it was 83%. And then the other one was 71%, right? So you can go ahead and use the relative frequencies from the table in step A to find the equivalent conditional probabilities. So basically, what is the probability of A given B? What was A anyway? What's the probability of participants not getting a headache, okay? Given that they took the medicine. So that means they took the medicine, okay, took meds, but they still had a headache. I mean, took the medicine, and then probability of A is, oh, the medicine fixed it, so no headache. Okay, so what is the probability of that? Well, in order for you to find that, you gotta first find the probability of B, and you already got that right here. That's 0.65 over there. And then the probability of A and B, who took the medicine and have no headache, and that one's here right here. So if you actually calculate this, you'll find out that this ends up being 83%, which is the same as the stuff you found on top. Same thing over here. Now this is the probability of B, meaning they already, what was probability A? They did not have a headache. They're weird, okay. They had no headache, okay. A is no headache. But then B is they took the medicine anyway. So why would they take medicine if they don't have a headache? I don't know. Do you take medicine when you have no headache? But anyway, they want to find the probability. What is the probability of the people who took the medicine even though they have no headache? Okay, so the probability of all the people who have no headache, the probability of A was 0.76, and the probability of the people who did both, okay, took the medicine and also had no headache, is over here, 0.54. So then when you actually divide that, you'll find out that you get 71%. And that is the same answer you had using the other chart, okay? So that's the most important thing. Okay, so you might be feeling lost right here, but you only have to remember one thing, okay? When you see something like this, okay, this is kind of important. You gotta write this down. Whenever you see something like this, the probability of A given B, okay, make sure you know how to read this. Oh, there you go, it's already here. The conditional probability of A given B, okay? That is the probability that event A occurs given that B occurs is like this. All you have to do is, oh, and this is actually wrong. Oh, yeah, it is right in your textbook, but for some reason in here, okay, it didn't come out right. So this is supposed to be B down here, okay? So whatever you have over here, that is the background, that's the base. So you put the probability of B down here, and then to find the probability of A happening is basically A and B both happening. So you put the probability of that on top. So, okay, if you see the probability of B given A, okay, then basically what that means is you have to find the probability of A down here because that's the second one that goes to the bottom. And then the probability of B, to find that, you basically find the probability of both A and B happening. And when you divide that, you'll be able to get your conditional probability, okay? So that is the most important thing that you have to understand. What I'm going to do is there's this one question that we have to solve, and then you're going to have two homework questions that has to do with this, exactly the same thing, okay? So what I'm going to do is first solve this together. Actually, it solved it for you over here, didn't it? That really sucks because I was kind of excited about doing this with you. Okay, so these are your your turn questions that you have to solve, right? You know what I'm gonna do? I'm just gonna let you do it on your own. Probably that a face card randomly drawn is a king. Okay, so I'm gonna go ahead and do the homework question. No, I'm actually going to do one of the evaluate questions. So actually you're supposed to do the evaluate questions in the classroom because you already learned the whole lesson at home, but a lot of you have been not doing that, right? Just want to remind you that all your test questions were actually from the evaluate section. Okay, so now let's take a look at this. Okay, so let's take a look at question number 1. I just want to do number 1 with you because you really have to work on the rest of them on your own in the classroom. And I did not want to do your homework question for you. So it says to the nearest percent, what is the probability that a student who failed the exam, we'll call that F, got less than 6 hours of sleep, we'll call that L. Okay, so then we're looking for probabilities. Okay, so that's the probability that out of all the students who failed, the exam, they got less than 6 hours. Okay, so what is that? Out of all the people who failed the exam, that's 18. How many got less than 6 hours of sleep? Less than 6 hours of sleep. Oh, that's it. Simplify is going to be 5 over 8. Now, I could try and make it more complicated and say something like, oh, in order for you to find this, first you got to find the probability of F, which means failing the test. Failing the test, there's 18. So it's kind of like 18 out of 120. Okay, and then here's the big division thing. And then out of those, we got to find the people who slept for less than 6 hours, which means I got to find the number of people who failed and also slept less than 6 hours. Who failed and also slept less than 6 hours. That's 10. And that's going to be 10 out of how many people? 120 people, right? So then if you actually calculate all of this, it ends up being the same thing, 10 over 18. You simplify. Oh, did I say 5 over 8? You can divide top and bottom by 2, so it's 5 over 9. You're going to get really mad at Miss Choi, like, for making all these mistakes, huh? Anyway, so there you go. Your answer is 5 over 9, but then it said to the nearest percent. So if you go 5 divided by 9 times 100, you're going to get 56%, and that's your answer. Now, believe it or not, this section is super easy, and I'm hoping by today you already did your homework, so you're reviewing some of your previous stuff, okay? I'm going to try my best to record another video on your test questions and the answers, so you can go ahead and figure out what you got wrong. But anyway, that's it for today. Goodbye. Uh-oh.